Hi there everyone, welcome to another video looking at one of the key questions from the Edexcel November 2014 non-calculator paper, and in this video we're going to be looking at question 18, so towards the end of the paper, so we're moving towards the A grade topics now, and this question is all about mathematically similar shapes. So you all have been taught this in the unit kind of with similar shapes and congruent shapes, and similar shapes, remember, are shapes that are scaled up or scaled down versions of each other. So everything remains in a proportion to each other. So the key thing we're looking for is the scalar or the multiplier. So let's have a look at the key information in this question. We're told that ABCD, so here, is a trapezium, and AEFG here is a trapezium, and they're mathematically similar. That means, as I just said, they're scaled up and down versions of each other, so everything's kept in the same proportion. We're given some of the dimensions, so AE in the smaller one is 5 centimetres, EF in the smaller one is 12, and BC in the larger one is 18. Work out the length of AB. So AB is this dimension here, so the longer side here in comparison to the shorter side here of the trapeziums. Now, the key to these questions is trying to find two measurements that you can make comparable. And what we can see here is that the longer base value here, I suppose if we were using the area of trapezium, the formula, kind of the length would be b here, we have these two dimensions given. So in the smaller shape, the dimension is 12, and in the larger shape, the dimension is 18. So what we need to do, we ask ourselves the scalar or the multiplier. How do I scale up from this value to this value? And the name multiplier means it's not an addition question, it's a multiplying factor. So what do I do here to get from 12 to 18? Well, if I times it by 1, I'd still have 12, so that's not got any bigger or smaller, it's just the same shape. If I times it by 2, so if I doubled the size of the shape, that would go up to 24, so that's too far. So it's actually gone up by 1.5 times. So one lot of this 12, half a lot of this 6, add them together, that makes 18. So I'm scaling up the smaller trapezium on a scale factor of 1.5 to get the larger trapezium. So if I know that the side length of the smaller trapezium is 5, then I can multiply that by my scale factor of 1.5 to get the similar length in the larger trapezium. So 5 lots of 1 is 5, 5 lots of a half is 2.5, 5 plus 2.5. So we've got a dimension there of 7.5 centimetres. Okay, let's move on to part B of the question then. It now tells us that the area of the trapezium AEFG, so that's the smaller one, remember, is 36 centimetres squared, and it asks us to work out the area of the shaded region. Really important there, because I know a number of students in 2014 missed this part. It's not the area of the whole of the larger trapezium, although we are going to need to find that. It's the area of the shaded part. So we'll find the bigger one, we'll take away the smaller one, and we'll be left with the shaded area. Right, here's the key misconception here. Students quite often assume that once you've found this scale factor, this scalar, this multiplier, that you apply it to all kinds of measurements within the calculation. This is a length scale factor. So it's important to note here that the length scale factor is 1.5. So imagine, if you will, and we're not going to talk about the trapeziums just for a moment here. Let's just pretend we were talking about cuboids, or cubes, squares even, because they're easier to kind of think about. If I had two squares, and this one had a dimension of, let's say, 2, and this one had a dimension of 4, then I could easily say that the length scale factor of these two here is 2. To get from this to this, I've times by 2. Okay, so that's a length scale factor. Let's keep with this idea, and let's pretend that I had those same two squares, so a 2 by 2 square and a 4 by 4 square, and let's pretend that I was now going to look at the areas of them. So the area of a square is the base times the height, just like with any rectangle, but it's special because it's 2 times 2. So the area of this one's 4, and the area of this one is 16. Now let's have a look at the scale factor here for areas. How do I get from 4 to 16? Well, I times it by 4 actually. So the area scale factor is times by 4. Or, if we could kind of come up with some kind of special relationship here, if you compare it to the length scale factor, I've times this length by 2, and I've also times this length by 2. So I've done 2 times 2, or I've done 2 squared, or I've done the length scale factor squared. And there's our relationship established. If we wanted to turn this into 3 dimensions, if we turn this into a volume question, which I know we don't need to for this one, but just to kind of support your understanding there. So imagine I now had cuboids rather than squares. I suppose I was thinking ahead earlier when I kind of got muddled up with my key terms. This is 2 by 2 by 2 and 4 by 4 by 4. So volume is those 3 dimensions multiplied together. So 2 times 2 is 4, times by 2 again is 8. So I've got a volume of 8 for this one. 4 times 4 is 16. 16 times by 4 is 64. And let's have a look at our volume scale factor here. 8 to 64 I've times by 8. So my volume scale factor has been times by 8. Or if we relate it back to the length scale factor, I've taken my length scale factor and I've cubed it, because I've done times by 2 in this dimension, times by 2 in this dimension, and times by 2 in this dimension. So 2 cubed. So this here is a really important part of your revision to understanding this topic. So let's apply that knowledge to the actual question we've got in hand here. So it says work out the shaded region, but before we get there we're going to work out the area of the larger trapezium. So if we're told that the area of the smaller trapezium is 36, what we're going to do is we're going to apply our area scale factor to that. Now, we were told that, we calculated that our length scale factor was 1.5. So our area scale factor, if you imagine now our 2D shape, is 1.5 in this dimension and 1.5 in this dimension, or 1.5 squared, which is 1.5 times 1.5, and that's going to be, well, one lot of this is 1.5, half a lot of this is 3/4, so 2 3/4, or 2.25. So I have a scale factor of 2.25 for the area. So I'm going to take my area of 36 and I'm going to scale it up by a scale factor of 2.25. Okay, so 2 lots of this. So we've got 36 and 36, and 0.25, a quarter of this, 9. So let's add all that together. 36, 36, that's 72, plus the 9, 81. So this 81, and what are our units? Centimetres squared. This represents, if you like, the area of the larger trapezium. Let's come back to the question, the shaded region. So what I have is the area of the larger one, which is 81. Subtract the area of the smaller one. And if you're thinking, why is he subtracting that there? Let's have a look. The larger one here, incorporating the entire diagram, is 81. I only want the shaded bit here, so I need to ignore this white shape here. So I need to subtract this area away from the larger one. So 81, take away 36, and that's going to leave us with 45 centimetres squared.